Hey everyone, welcome to Knowing Nuclear. In this episode, we are going to be talking about how nuclear reactors are heat engines. A heat engine is a device that allows us to turn heat energy into motion. We have lots of heat engines in the world, including cars, trucks, buses, trains, airplanes, boats. But for this particular video, what we're going to focus on is power plants. Most power plants are heat engines. Any source of heat at a high temperature will work. We've talked in other videos about fuels. Fuels are dense sources of energy that are consumed when used. So if we have something like a nuclear fuel, like uranium, it's getting consumed. And when it gets consumed, it gives off a lot of heat. A heat engine is what allows us to turn that into something useful. You can imagine you have a piston where you put in some heat and that causes the gas to expand. Well, if you're expanding, you've got some force moving through some distance. That's a transfer of energy that's doing work. You then have to have heat come out, and then you restart this with a new mass, and you can lift a mass over and over again. Your car, for example, is actually doing this roughly 50 times every second. A power plant works in a similar way as a car engine. So instead of a piston, imagine that you have a turbine and a boiler. This is a very general diagram of a steam turbine power plant. In a coal-fired power plant, the fire in the boiler is created by burning coal. In a nuclear power plant, the heat in the boiler, more commonly referred to as the calandria, comes from a really hot nuclear fuel bundle. So we put the fuel into the boiler, and that is going to make heat go into our water. Once that heat goes into our water, that turns the water into steam. The steam pushes a turbine. This is sort of like a fan blade. This gives us work that can come out and do something useful, like make us electricity. The water then goes around to the condenser, and that condenser actually allows the waste heat to be removed and taken out and pumped into something like a lake. We have to pump the now cool water back into the boiler so that the whole cycle can repeat itself. We have a closed loop of water circling around over and over and over again. Now, nuclear reactors are heat engines. Here, for example, we have the US design, the boiling water reactor. The reactor vessel is the only part that actually has the nuclear reactions taking place. So the reactor vessel has nuclear reactions turning the water into steam, boiling it, hence the boiling water reactor. That steam then pushes the turbine, which is attached to a generator which has magnets and a loop of wire, which is making electricity to go out to your community and, say, turn on your street lights to keep you safe at night. So once the steam has turned the turbine, it has to go over the condenser. As it goes over the condenser, it loses heat. That heat goes out into the environment, and the steam turns back into water in the closed loop, and it goes around again. A slightly different reactor design is a pressurized water reactor. And in this case, the reactor vessel is in a completely closed loop that is under pressure. That pressure is enough to keep the water from turning into steam, hence the name pressurized water reactor. You then have the heat exchanger where the heat moves from that loop into the steam generator loop. And that steam generator does have water that boils into steam, pushing the turbine. And once again, you have the generator in the condenser and the cycle repeats. The US has both boiling water and pressurized water reactors, and both are heat engines. Canada made a really cool design called the CANDU reactor. And just like the boiling water and pressurized water reactors, it produces waste heat, which means it sometimes produces steam, but it does not produce smoke. The waste that comes out of a CANDU reactor is a solid waste. That solid waste can be safely handled so that it's stored until it's ready for a deep geological repository, which we're going to cover in a different Knowing Nuclear video. So for example, here is the Bruce Nuclear Power Station. There are 8 nuclear reactors. This one site produces 1/5 of all of the electricity in Ontario. There are other nuclear sites as well, like Pickering and Darlington. The combined nuclear power in Ontario from just a handful of sites actually produces 3/5 of all of Ontario's electricity, which is really pretty incredible if you think about it. It's all being done locally, and all of the potentially dangerous spent nuclear fuel is safely stored on site, so it doesn't wind up getting out into the environment or affecting people. Nuclear reactors are really just another useful heat engine.